Thank you for joining me on Project X Statistics YouTube channel. Today we are going to continue on the part 2 of the topic understanding hypothesis testing, significant level, test statistic and p-value in research analysis. I want to first of all encourage you to watch the first part of this video before coming on to watch this particular second part. In this video, we are going to learn the 4 steps of hypothesis testing. We have already discussed the very first step in hypothesis testing in the first part. I encourage you to watch that video. Here, we are also going to talk about the criteria for decision making, the meaning of significant level, and how to use it in research analysis. We are also going to talk about how to interpret the test statistic, what the p-value really tells you in research and in hypothesis testing, how to make decision using the rejection zone and the critical value, and more importantly, we'll also talk about understanding the decision rule. So I really want to encourage you to watch this video, whether you are using SPSS or you are using Stata or R, or you are just starting to learn statistics. I want to encourage you because this video is going to give you a good foundation for a good understanding of decision making in research. The goal of hypothesis testing is to determine the likelihood that a sample statistic will be selected if the hypothesis regarding a population parameter were true. Now, in the first step of the hypothesis testing, we discussed the states, we discussed in the first part of this video, the first step of hypothesis testing, which is state the hypothesis. Then the second step is setting the criteria for a decision. Step 3 is compute the test statistic. And step 4, make a decision. To set the criteria for a decision, we state the level of significance for a hypothesis test. This is similar to the criterion that jurors use in a criminal trial. Jurors decide whether the evidence presented show guilt beyond a reasonable doubt, and this is their criterion. Likewise, in hypothesis testing, we collect data to show that the null hypothesis is not true, based on the likelihood of selecting a sample mean from a population. Now, the level of significance is a criterion of judgment upon which a decision is made regarding the value stated in a null hypothesis. The criteria is based on the probability of obtaining a statistic measured in a sample if the value stated in the null hypothesis were true. Now, in science and in statistical research, the criterion or the level of significance has been typically set at 5% or 0.05. So in statistics, it has been statistically proven that the criterion or the level of significance is 0.05. So the level of significance in hypothesis testing is a criteria we use to decide whether the value stated in the null hypothesis is likely to be true. So when the probability of obtaining the sample mean is less than 5%, we reject the null hypothesis. So this is the criteria. The criteria is the 5%, the 0.05. So if our probability of obtaining a sample mean is less than the 5% level of significance, we reject the null hypothesis. Then we conclude that the sample we selected is too unlikely. On the other hand, when the probability of obtaining a sample mean is greater than 0.05, we fail to reject the null hypothesis. And this probability is stated as p-value, also known as SIG2 tell in SPSS. When you run your SPSS, the column known as SIG2 gives you the p-value. And this p-value, when you have the output from your SPSS, the p-value is being compared with your level of significance, which is already known to be 0.05. So in order to reject or not to reject the null hypothesis. So this is what you do when you want to um, either reject the null hypothesis or not to reject the null hypothesis. You compare the probability value with the level of significance, which is our criterion of judgment to know whether you're going to reject or not to reject. Now, the step 3 is to compute the test statistic. Suppose we measure a sample mean equal to 50 university students, which is regarded as a sample that spent money buying recharge card. We did not observe everybody in the population. So to make a decision, we need to evaluate how likely this sample outcome is if the population mean stated in the null hypothesis is true. So to determine this likelihood, we use a test statistic which tells us how far or how many standard deviations a sample mean is from the population mean. The larger the value of the test statistic, the farther the distance or the number of standard deviation a sample mean outcome is from the population mean stated in the null hypothesis. The value of the test statistic is used to make a decision regarding the null hypothesis. Step 4, make a decision. Now, before we make a decision, we use the value of the test statistic to make a decision about the null hypothesis. Now, what happened is that we compare the test statistic to the critical value to make a decision, or we use the p-value. As I said earlier on, the p-value is compared with the criterion, which is 0.05, to make a decision. So what it means is that we have two um, situations that we can use to make a decision. The first one is that we compare the p-value from the software output, we compare it with the criterion, which is 0.05, in order to make a decision. Another way of making a decision is to compare the test statistic to a critical value. Now, we think of the test statistic as a standardized score like the Z-score or the T-score that shows how much the sample data differs from the hypothesis. It answers the question, is this difference big enough to be considered statistically significant? The critical value in this case is the cutoff point on the distribution curve that defines the boundary between the rejection region and the non-rejection region in hypothesis testing. And this value is 1.96. It separates the rejection region from the non-rejection region. Now look at it here from the diagram. I have the I have the distribution curve here. As you can see, the rejection region is, we have plus or minus. On the minus side, we have minus 1.96, this side minus 1 plus 1.96. So from this line here, anytime our t statistic falls in this region, we are going to reject the null hypothesis. But look at the non-rejection region, is anything below 1 point plus or minus 1.96. So in this region, you can see that this region is a non-rejection zone. So the standard normal distribution with the rejection zone clearly marked in red for a two-tailed hypothesis test at a significance of 0.05. So the critical value here is plus or minus 1.96. If your test statistic falls below or beyond this value, left or on the right tail, it lies in the rejection region, as I said earlier on. Otherwise, it falls in the non-rejection region. Now, what is the rule for making the decision? If the t-statistic falls in this rejection region, that means, or another situation is that if the p-value is less than the significant level of 0.05, then we reject the null hypothesis. What it means is that your sample provided enough evidence to reject the null hypothesis. There is enough evidence to reject the null hypothesis anytime your t-statistic falls in this region that is beyond the critical value. Otherwise, if the t-statistic is not in the rejection region, or that your p-value is greater than 0.05, you fail to reject the null hypothesis. It means that there is insufficient evidence to reject the null hypothesis. There is insufficient evidence to reject the null hypothesis. So I have an example here to demonstrate what we have been discussing in this video. As you can see, our t-statistic here is about 6.657. 6.657 is beyond the region, is actually way above 1.96. So it's definitely going to be in the positive region, that is in the rejection region. So here, if you look at this, you can see that we're going to reject the null hypothesis because this value is above 1.69 or 1.96, which is the critical value. So it falls on the rejection zone. On the other hand, we can also use the p-value, which is known as the 𝐭𝐡𝐢𝐤. If the p-value is less than 0.05, we also reject the null hypothesis. So in this case, we are going to reject the null hypothesis because our p-value is less than 0.05. So you see that it's either you use your t-statistic and compare it with your critical value, or you use your p-value and compare it with your criterion, which is the level of significance, to make your decision. So if you understand this in statistics and in hypothesis testing, you'll be able to make your decision at any point in time. So in decision making, the decision to reject or retain a null hypothesis is called statistical significance. So when the p-value is less than or equal to 0.05, we reach significance. In other words, the decision is to reject the null hypothesis. But when the p-value is greater than 0.05, we fail to reach significance, and the decision is to retain the null hypothesis. I want to encourage you to kindly like this video, share it, and also subscribe to our channel so that you get more of this kind of videos when we post our next video. So I want to encourage you to do that, and thank you for watching.